I reject your reality and substitute my own.
Yeah, so if you know that fun show, Mythbusters, that's what they say. You can't reject your reality and substitute your own. Everyone's got the same reality, right? So this rule doesn't work, right? And what it all comes down to, as you see here, scientists assume that the universe is publicly understandable. That we can come to understand it by interacting with it, by experimenting with it, by agreeing on the criteria of evidence that we're going to use, right? And we can all interact with it publicly, communicate our knowledge, and come to the same understanding about what's going on. There's no hidden knowledge. There's no mystical revelations that we revolve on. Everything has to be out front, well explained, testable by others, verifiable by others. That's what it means to be a scientist. All right? All right, so there we go. Scientists assume that the universe is publicly understandable. All right, so now we've got those things laid out. Well, now we know the basic things you have to assume in order to say that you're doing science or you have something scientific in your hands. I want to try to clarify some vocabulary that you may have heard, in the past that surrounds science. And these three words are fact, hypothesis, and theory. And so I want to just lay them out the way I'm going to take them in this class, the way we take them in this class, and hopefully they'll make sense to you. So what is a fact anyway, right? What is a fact? Well, from the perspective of this class, a fact is a statement concerning a direct observation of nature that's so consistently repeated that virtually no doubt exists as to its validity, okay? So the sun comes up in the east, and by east I mean, I think, we're a little disoriented, I think in that direction is east, and we can all verify that. We can all look over there tomorrow morning and verify. We see it over and over again. That's a fact, right? Direct observation where the sun is coming from. All right, so that's what a fact is, and virtually no doubt, virtually no. Because this fact is just based on everything we saw in the past. It could be possible that tomorrow morning the sun's going to come up over there. So we have virtually no doubt that this is true, and someday in the past it might have come up in the west. We have no real reason to imagine that, but so it's virtually certain, though. All right, so that's what I mean by fact. It's a tiny little nugget of knowledge in itself, doesn't really have any explanatory content in it. All right, what about hypothesis? We dealt with hypothesis last time. And a hypothesis is a possible explanation for an observed phenomenon. That is, it's a statement about a possible cause of something. And there's all kinds of hypotheses that are out there. Some, as we see, are scientific. Some are not scientific. All right, so that's what a hypothesis is. We can distinguish between tested and untested hypotheses. Right? So some ideas people have had, they've never been tested or haven't been tested in that situation yet. Sometimes they have been tested, in which case you want to know how they came out, so you can decide whether it was a good idea or not. So we want to distinguish between tested and untested hypotheses. We can distinguish between good and bad hypotheses. And by good and bad, I don't mean good and evil hypotheses, right? By a bad hypothesis, I mean one that results in predictions that aren't supported when they're tested, that don't come true when they're tested. Good hypotheses are ones where you get a nice match between what's expected and observed when you test the hypothesis. All right, so that's good and bad hypotheses. We want to distinguish between those, obviously. All right, now let's move on to theory. What do we mean by theory? Theory is a word that gets thrown around a lot. A lot of times, actually, people use theory when they really mean hypothesis. You should not make that mistake in this class, which is a hint about quizzes and exams. But in any case, so theory. So let's talk about theory. What does we mean when we talk about a theory? A theory is a bigger thing. It's a bigger construct. All right, and we'll get to that. So sometimes you hear people say, well, that's just a theory. That's just a theory. And what they're sort of saying, that's just a wild guess, right? There sort of has this negative connotation. That's just a theory when you say something. So let's think about that. So let's think about some of the theories that we have are in science. So for example, we have Einstein's theory of relativity, right? Pretty famous theory. Just a wild guess? No, right? One of the most powerful and amazing ideas that anyone has ever come up with to explain the nature of matter and all its interactions. It's a big complex that applies to light and stars and electromagnetic radiation and atoms and all kinds of things and all the relationships therein. So, and it's not just a wild guess, right? In this case, it's very, very powerful and effective, right? So theory, so what is a theory then? A theory is a big thing in science. It's a collection of things. It's a collection of interrelated things. Assumptions, postulates about what's going on, hypotheses about causation, that when all taken together seek to explain a set of related phenomena. So here in the Science Museum, in different parts of the museum, you can see different theories are on display. On the second floor with the physics, we have Newton's theory of gravity and gravitation. theories of electromagnetic radiation. We talk about light, theories of neurons and brain function over there, all related to here the theory of evolution by natural selection in case of biology, right? They're all, a given theory has a domain, but it has a lot of pieces, a lot of different hypotheses, assumptions, and connections among them. That's what a theory is, okay? Now, it's important to distinguish between scientific and non-scientific theories. So how do we do that? We use the assumptions of science. If you have a theory that violates one or more of those assumptions, you have a non-scientific theory on your hands. So for example, flashlight fairy theory is a non-scientific theory about why flashlights don't work, right? Because we can't know anything about all-powerful, unobservable fairies, right? So it's a non-scientific theory. It could well be that fairies control flashlights and whether they work or not, but we can't really test a non-scientific theory, all right? There's also the idea that there's good and bad theories. Again, these aren't good and evil theories, right? Good theories are ones that are effective. They survive, their components are sound. They've been tested many, many times. They work. They help us invent technologies like laser pointers and other sorts of cool things. That's a good theory. Bad theories are made up of broken parts, parts that don't work when they're tested, parts that don't make any sense, parts that are untestable. Those are bad theories, okay? So it's important to distinguish among them. So in this diagram, you can imagine then, right, that we could use this way of thinking to subdivide all the theories we may ever have in front of us and consider that people have taken into consideration over time. We take into consider the group of all theories. We can talk about the theories that don't meet the assumptions of science. Those are the non-scientific theories. So, for example, matrixism. Maybe you have a theory related to ideas like in the movie The Matrix. Creationism, we'll talk about later, is a non-scientific theory about biological origins. Evil spirit disease theory. Lots of peoples in the past thought diseases were caused by transmission of evil spirits. Right? Now we have ideas of germs and viruses and bacteria. Right? Flashlight fairy theories and other non-scientific theories. Many, many non-scientific theories. However, if you have a theory that meets all the assumptions of science, then you have a scientific theory. Now we can distinguish between tested and untested scientific theories. There aren't very many untested scientific theories that I can think of. The only one I can think of is called string theory. It's in physics, and only like 5 people in the universe actually understand string theory, and none of them have figured out a way to test it yet. It's just a bunch of equations. On the other hand, most scientific theories have actually been tested over time, and so we can distinguish between the good theories and the bad theories. There's a lot of bad theories out there. There's a lot of things that people have thought of in the past that turned out to be wrong. And there's a list of them here, right? Some of which we'll talk about. Flat Earth theory, right? A theory about the shape of the Earth. Wrong, wrong, wrong. A lot of people thought that was a true idea. The Ptolemaic theory of the solar system, where the sun revolves around the Earth and the Earth is in the center. Now it's been replaced by a good scientific theory called the Copernican theory, where the sun is in the center and the planets move around it, right? Because it fits the data better. It's a good theory, all right? So that's how we use theory. It's a big idea. And hopefully you'll understand how those things come together. So fact, hypothesis, theory, think about them, work on them, and hopefully you understand how to distinguish them from each other.